Okay, so the method of isoclines. First, you're going to sketch various values of C corresponding to those isoclines, f of t, y equals c. At representative points on the curve, you're going to sketch the little arrows. And then given a point that the solution passes through, you can sketch a solution, okay? So here is my direction field that I want to plug in, and I want to find different isoclines. So y minus t equals some constant. There's my isocline formula, or y equals t plus c. This is just a line with slope 1, right? But the plus c just translates it up and down, which we know that these functions, these translations, we've sort of talked about this before with integrals. Okay, so let's pick some constants. We want to sort of be in this realm, so let's pick, you know, like t plus 1. That means the slope is 1, right? Because my constant, whatever my constant is, that's my slope. So t plus 1 would look like this, and I'm going to dot it. I'll just draw it real light. And so here, my slope is 1, and this slope actually already has a slope of 1. So wherever it is, I'm just going to follow the slope here. Okay, now let's do a slope of 2. So I just plug in 2 there. T plus 2 is on this line. They both have a slope of 1. I think, yeah, you can see that. But now my slope is 2, so it's steeper. So I'm going to make it a little steeper than this line. Okay, so what about a slope of 3? So I make that c equal 3. So t plus 3 will look like this line. You just can't see that it crosses up here. And I'm doing this fast graphing these, but that's because I'm very comfortable graphing. And so this is, if you aren't comfortable with graphing, you need to review those again. And so my slope is now 3, and let me draw my 3, and they should be even steeper than this because the slope of 3 is even steeper. And I have one more point here, and that's y equals t plus 4, and it's the only one. It would extend here, but we would have it going there, and so this would be even steeper. Okay, but now we want to go less, so let's do a slope of, so I started at 1, a slope of 0. And the slope of 0 would be on this line. So this is the green is my isoclines. And the purple are my slopes. These are slopes of 0, and 0 looks flat, right? That's how I would draw my slope. And now -1. So now these slopes should be going down. Little arrows. It should look nice and symmetric here because that's 1 and -1. And then we have -2 is my C. Remember, I'm just choosing different constants until I fill this all up. And I know that whatever I choose the C to be, that is my slope. That's how it works. I'm saying that the derivative equals that number, and so that means the slope is that number, right? So -2 is steeper. And then we want y equals t minus 3. This one is -3. And then here it's even steeper. That'll end up being -4. Okay, so now I want to start at -1, -1/2. And so let me get one more color here. So this means t is -1, so that's here, and y is -1/2. That is here. So now anytime I cross an isocline, I want to change in that direction. So if I go this way, this is going to be somewhere in between here, right? So let's actually just find the slope at this point. What is the slope at this point? I'm going to find sort of my starting slope here. So that's y minus, I'm just plugging it into here, t. So this is negative 1/2 plus 1. This is a slope of 1/2. So that's like positive, but it's kind of flat. So I come here, and now I'm crossing an isocline, so that means I need to change flat. And then I'm crossing an isocline, so I need to slope down, and you just want to make these kind of smooth. And I'm going to get steeper again, and then steeper again. And then I do want to come this direction. So there is my solution. So notice anytime I cross an isocline, I want to start changing direction. Even though I didn't technically cross at one of the points I chose, I still cross some isoclines. So that's also helpful to be able to draw these solutions.